Okay, hello, my name's Anna Gale and we're going to look at a Year 6 lesson based on fractions, decimals and percentages. So before I would go through any sort of teaching, we'd go through key vocabulary. So for this lesson today, the children will need to understand the term equivalent, which means the same. Proper fractions, I've given an example there, 12 over 40 or 12 40ths. 12 is where the numerator is smaller than the denominator, so the children need to understand that terminology because we won't be looking at improper fractions or mixed numbers. Simplest form, it means a fraction cannot be reduced anymore, and they're again proper fractions. The knowledge, there's a lot of knowledge in this lesson and it's using facts that you already know, and the skills, we might be revising a skill, or for some children it will be new learning. So, our starters at Hampton Juniors involve a teacher modelling maybe a question that some of the children have found quite difficult to answer, or if there's misconceptions. So for example, in this particular instant, we've got 0.9 divided by 10. In the Year 6 curriculum, they have to be able to divide and multiply by 10, 100 and 1,000. So the children would watch the teacher input here. So at this point here, I would write it down. So 0.9 divided by 10 equals. So for some children, they'll visually be able to see that and they will move the numbers accordingly. For other children, they won't see that, and we would encourage them to draw a place value grid. So I tend to ask my children in my class to draw 5 lines and draw a decimal point on that middle line. We then put 0.9 into our place value grid, which is 0.9, which would go here. Now, to be more specific with the columns, you can label them. This is your ones, this is your tens, this is your tenths after the decimal point, this is your hundredths, and this is your thousandths. Okay. So when we're dividing by 10, the children need to know in their place value grid that if we're dividing by 10, we're going to move to the right because the number is going to be getting smaller. If they were multiplying by 10, they would move the number to the left because the number would be getting larger. So 0.9 divided by 10, there's 1 0 in there, which therefore means we'd move each number over 1 time to the right because we're dividing. So the 0 would come here, the 9 would go here, and the children will often say, well, what number would go there? And actually you want the children to say, well, that's a placeholder there, so what would go there? 0, okay? So 0.9 divided by 10, my answer would be 0.09. It's really important that that decimal point looks like a point and not a comma. Actually, that could look very different. Now, at this point here, we would then give the children 6 questions similar to this. You can notice here I've got divided by 100. So I may just recap on that and actually say to them, if I was going to do the sum here of 0.9 divided by 100, because there are now 2 zeros in the 100, we would move each number over twice. Okay? So the 0, 1, 2 would come here, the 9, 1, 2 would go here. And they would also need to put a place value holder in the tenths column and in the ones column. And your final answer would be 0.009. So at this point in the year, we're just refreshing on it, and then the children have a go. We will give them usually between 6 to 8 minutes. For those children that will get through that pretty swiftly, we then have some extension questions. All of the children have to start from question 1, work their way through to 6, and if they finish, they work on to here through silver, gold, platinum and emerald. So we'd give them 6 minutes. So at this point in the video, I'd ask you to pause it, have a look at those questions, give your child about 6 to 8 minutes. So it's really important that the children are able to self-assess at this point. We would then put up the answers and we would allow children to self-assess their work. If there were any misconceptions, or for example a child wanted one of these questions modelled, we would model that. So take the time to self-assess your work. At this point here, we'd move on to the learning objective and we would read this chorally. So read this with me. LO. To use and apply our knowledge of fractions, decimals and percentages. Now you can see here I've snipped a question from the actual 2019 paper, and it was a reasoning paper. We wouldn't model this at this point, it's just so the children get an idea of what type of question we're going to be looking at. So in order to answer this question, we would need to practice 2 skills, and all the children take part in this. And skill 1 is to memorise equivalent fractions, decimals and percentages. So at this point here, maybe draw upon the fact, what does equivalent mean? And actually in our vocabulary here, equivalent means the same. So, to begin with, we would have a look at these pictorial representations. And we've got a variety of different ones here. And we would go through each part here. And you can see here it says, I say, we say, you say. And what that means is, I'm going to model how to say it, we as a class would say it, and then I would ask individual children, maybe 2 or 3 children, to say it. So, watch me. 1/2 is equivalent to 0.5, which is equivalent to 50%. Have a go at saying that. Okay. 1/4 is equivalent to 0.25, which is equivalent to 25%. Again, the children would have a go at saying that. 3/4 is equivalent to 0.75, which is equivalent to 75%. And we have the last two here. 1/10 is equivalent to 0.1, which is equivalent to 10%. And 1/5 is equivalent to 0.2, which is equivalent to 20%. We would then say them as classes, and I would ask individual children to say that term in a full number sentence. It's really important that children see the links there between the fractions, decimals, percentages, and understand what does that look like mathematically. So, once they've had a look at that grid, I would then encourage the children, I've got some missing boxes here, and with the partners, you'd have a minute to discuss what would those missing red boxes be, and I'd give them a minute. So have a go at that yourself. Okay. Now then we move on to skill 2 before we look at that question there. And skill 2 is reducing a proper fraction to their simplest form. Again, we've got the definition of a proper fraction and what the simplest form is. So, you can often see here there's a watch me, help me, and then we will ask the children to show me. So for the first part here, this is all teacher modelled, so the children need to watch this. So I'm going to reduce 15 over 60, or 15/60, or some children might say it's 15 divided by 60. All of the same thing. Okay, so 15 over 60, I'm going to reduce it to its simplest form. Now some children will see there that these are both, we need to look at what the multiple is. So these are both multiples of 5, and they can see that because both of the numbers, the ones column end in a 5 or a 0. Some children will see that they're both multiples of 15, and they'll be able to reduce it very shortly. However, we'll look at what the majority of children would say, and it's both multiples of 5. So whatever we do to the numerator, we do to the denominator. So 15, if we divide 15 by 5, our answer is 3. If we divide 60 by 5, our answer is 12. Can we reduce this fraction again? Yes, we can. It doesn't have to be multiples of 5 anymore, we'd look at a different number. So both 3 and 12 are both multiples of 3. So whatever I do to the numerator, I do to the denominator. So 3 divided by 3 gives me 1, and 12 divided by 3 gives me 4. So if I reduce 15/60 to its simplest form, it is equivalent to 1/4. Those children might say you might not need to do this middle step, because actually if you saw 15 over 60, if you saw they were multiples of 15, you could say 15 divided by 15 gives you 1, 60 divided by 15 gives you 4. And actually you've just missed that middle step there because you've seen they're both multiples of 15. At this point here, I would then ask the children to help me with this question here. How could I reduce 20 over 100 or 20 hundredths to its simplest form? And the children would work with me on that particular part. I would then ask the children to work independently of this task on these questions. All the children start from the same questions. They start from question 1 and work their way through to question 8, and they need to reduce these fractions into their simplest form. For those children that are more able children and want a bit more of a push, we've got some problem solving here. So how many ways? Make all the fractions that are more than 50% and less than 75% using these digits here. And those would be for those children that need more of a challenge. So I'd usually give them 2 minutes, 2 to 3 minutes to practice this skill. So off you go. Now once they've had a go at this particular task, we would then self-assess it. So it's really important here that the children are accurate in reducing their fractions to their simplest form. If at this point we had a couple of children who got these incorrect or misconceptions, we may model them, or we'd use an adult as extra support to support those children. So the next part is, once we've done both of those skills, we then need to do the application of skills, which is really important. So again, you've got the watch me, help me, and then the children will show me that they can do it before they move on to the task. So this is the question, question 15, from the middle of a reasoning paper. It is based on the expected standard in year 6. So we've got the lovely Amina. Amina asked 60 children to choose their favourite flavour of jelly, and these were her results. You can see in the table there. What percentage of the 60 children chose orange? Now, first of all, how many children were there in total? I need to know that. There were 60. And they're asking me for percentage, and they're asking me which chose orange. So I have to have a look here over at orange, and there was 15 children. So, first of all, I'm going to put that information about the total number of children and how many children chose oranges into a fraction, which would be 15 over 60, which is what we looked at earlier, if you can remember from the skill before. So before I do anything, I'm going to reduce this fraction to its simplest form. So for those children that can see that common multiple of 15, you can reduce it to 1 over 4, or 1/4. For those children that can't see it, they'll reduce it by multiples of 5 and then multiples of 3, and they'll eventually get to its simplest form. I then need to draw upon my knowledge. What do I already know? And this is, again, coming to the knowledge here, using the facts that we already know from earlier on in the lesson. 1/4 is equivalent to what percentage? Now, that's what they're asking me. However, I can draw upon what I already know. 1/4 is equivalent to 0.25, which is equivalent to 25%. So actually, what percentage of 60 children chose oranges? Well, I had 15 out of 60. That's equivalent to 1/4, which is equivalent to 25%. And this is where I'm drawing all upon my knowledge of fractions, decimals, and percentages. So in my answer box here, I would jot in 25. Now, they already give me the percentage sign, and it's worth 1 mark there. At this point here, I'd then ask the children, how confident are you with that? How do you feel about that? Yes, middle, no. If you were maybe a middly, or if the children were not here, or here, we would look at this part here together. So again, I've kept the same style of the question. The only thing I've changed are the numbers. So it's applying that skill in the same way. It's not a different question. It's just that same skill. So have a go at that, because I'd ask children to help me with that particular skill. Have a go. Okay. Let's model that one then. And at this point here, rather than actually me modelling it, I might put an example of child's work up on the board, talk it through, or if there was a lot of misconceptions, I'd get a child to come up and model rather than myself. So we've got 80 children now, changed that total number, and chose orange. We're still looking at the orange, which was 60. Okay. So again, coming back to that skill, I need to put it into a fraction first, 60 out of 100. Reduce that to its simplest form. You're hoping at this point...
It's 60 out of 80, Mrs. Gale.
Oh, thank you, Miss Smith. 60 out of 80. So you're hoping at this point here the children can recognise that these are both multiples of 10 because they both end in that 0. So 60 divided by 10 would give you 6. 80 divided by 10 would give you 8. This can still be reduced though, because they're both multiples of 2, because they're both even numbers. So 6 divided by 2 gives you 3. 8 divided by 2 gives you 4. So 60 over 80 reduced to its simplest form would be 3/4. I then draw upon my knowledge of fractions, decimals, and percentages. 3/4 is equivalent to 0.75, which is equivalent to 75%. So, what is my final answer? It is 75%. This point here, I might ask the children how confident they are. And I now really want to be able to see that they can do it independently. How confident are they to do it independently? And I'll be able to see very much who I need to support in my class. So, same question, different numbers, have a go. And actually, I hope your final answer, when you look at that here, so again, you were looking at orange, which is 20 out of 100. So 20 over 100. You can see actually that they are both multiples of 20. That's going to be much quicker to reduce. 20 divided by 20 gives you 1. 100 divided by 20 gives you 5. 1/5 is equivalent as a percentage, can you remember, to 20%. Okay, so your final answer here was 20%.
Would you not also agree, Mrs. Gale, because the number's already over 100 and percent is out of 100, that you just need to add the percentage sign to the 20 at the top as well?
You could. That's another way of looking
top tip.
Thank you, Miss Meir. Another top tip there from Miss Meir. Thank you. So at this point here, we've done the input, we've done the starter, we've done the input, we've built up on our skills. We would now give the children the time. So I break the time up into the task into 2 lots of timing. So I'd give them 10 minutes to start, and I'd stop after 10 minutes, and I might give them another 10 minutes after that to have a look at maybe gold, okay? All children start from bronze and work their way through, and the reason why we do that as a school is so we can see if there's any errors or any misconceptions. So now's your chance to work independently. You can see on your sheet, bronze is to start simplifying these fractions to their simplest form. Silver is then that application which we've just shown. So there's 4 questions on there. I wouldn't talk too much at this stage about gold, but I will have some children that will go through that bronze and silver pretty swiftly and accurately, and they will need to move on to some problem solving. And you can see here I've got a variety of gold questions, and then some platinum questions, and some real problem solving later on for emerald. For those children that get through all of emerald, which we do have here, they then look into an extension, which is again a lot more problem solving and a lot more calculations. All linked though to that part, that learning objective where we're looking at fractions, decimals and percentages. So I would now give you 10 minutes to start working your way through the tasks. Off you go. Now, after those 10 minutes, I would choose one of these gold questions to model. If most of the children have flown through those gold questions, I would then as a teacher make the decision, well, maybe we'll have a look at platinum. Okay, so actually as a teacher I have to make that judgment call on where the most of my class are at. However, for this particular video, let's have a look at this gold question, question 2. So, some of you may recognise these are from lots of past stats questions here, and we're looking at various different types. So tick the fractions that are equal to 20%. Okay, the children need to have that prior knowledge, that 20%. What's that equivalent to? That's equivalent to 1/5 as a fraction. I don't need to know my decimal here because they're not asking me anything to do with decimals. I do need to see which of these fractions, if I reduce them to their simplest form, would be equivalent to 1/5. And also we encourage the children to use process of elimination. Well, which ones aren't going to work straight away? Okay. 1/20, can that be reduced to its simplest form? No, it's already in its simplest form. And is that equivalent to 1/5? No. 20 over 40, well, they're both multiples of 10. How many 10s go into 20? Would be looking at 2. How many 10s go into 40? Looking at 4. That can be reduced further. Because I could have seen that 20 and 40 are both multiples of 20, and that would reduce me straight into a half. Is a half equivalent to 1/5? No. Well, 1/5 is equivalent to 20%. I already know that because that's in my long-term knowledge. Okay, that's in that sticky knowledge that's got to stick with me. That's one. And it says tick the fractions. That implies that there's going to be more than one. 3/15. Well, if I reduce that to its simplest form, they're both multiples of 3. 3's into 3. If I divide 3 by 3, it gives me 1. If I divide 3 by 15, it gives me 5. So therefore, 3/15 is equivalent to 1/5, which is equivalent to 20%. So I must have to tick that one. Now this one here, 2 over 100, that can be reduced, but I can already see that actually that's not going to be nowhere near 1/5. However, some children will need to do that process to realise that. And actually, they're both multiples of 2. How many 2's go into 2? 1. How many 2's go into 100? Well, it's the same as 100 divided by 2, which is the same as calculating a half of 100, which is 50. 1/50th cannot be reduced anymore, so it won't be equivalent to 1/5. So actually this point here, I would model maybe a part of gold. However, in this instance, I modelled all of it, so you can kind of see exactly where I'm going. I'd model a part of it, and actually a lot of those questions involve that process. This one here, you're looking more of a wider range here. You're looking at decimals and fractions, not the percentages. This one here, they're having that application there as well. So after those 10 minutes, I then give the children another 10 minutes to work through some of those problem-solving questions. So you can pause the video at this point and work through some of those, maybe those gold ones and platinums. And for those more able children, working through the emerald. Now, as teachers, we will often have these answers pinned around the room. So rather than the children coming towards us asking us, is this question right, is this question right, the children have ownership of going and having a look and checking as they go. If they make mistakes as they go, they need to edit that in purple pen. So at this point here, I would allow a significant amount of time for the children to self-assess all of their work. What have they done so far? And if they have highlighted something in green, for example, yellow is accurate, green is inaccurate, we would say to children, right, go back to that question, have a look at it, maybe with a partner or a teacher or an LSA, and redo it and do it in purple pen so we can see where the errors are. So do have a mark of your own work. Now after that, there's the emerald and both of the extension questions here as well, so do have a mark of that as well. Okay. Now after that, we have reflection shapes as a school, and we ask the children to write a written reflection in year 6 into their books. What will I remember most from today's lesson? Now it has to be linked to the learning objective. We don't want it too vague for year 6. We want it very specific. And actually for some children, it may be as simple as, I need to memorise my fractions, decimals and percentages, the equivalents of them. Okay? Very, very specific. Some children might need to say, I need to remember that actually, and having been a year 6 teacher for many years, this one here, a fifth, is equivalent to 0.2, is equivalent to 20%, is often the one that they really, really need to memorise. They're quite familiar, most of the children, with these from previous years, but it's just maybe these couple of ones at the bottom. So at this point here, as a teacher, I would model what this reflection would look like. Okay? So I always get them to address it to me, so I'd say Mrs. Gale. From today's lesson, I will remember that. So they don't have to write whole full sentences, they can shorten that. They might have to say, like, I need to remember that a fifth is equivalent to 0.2, which is equivalent to 20%. And we encourage the children at our school to write like that, to shorten that into something that's manageable. And as a teacher, therefore, I know what that child needs to memorise. Okay?
Or has memorised today.
Or has memorised, yeah. And at the end of the lesson, we then see whether they can apply their knowledge to a question. And this is a raffle. So you can do this at home, you can do this with parents, you can do this with friends, and we give them a specific time limit. So this is the question. It's a slightly different question, but it's seeing whether they can apply it. And I'll just read it to you. So Hassan scores 40 out of 80 in a test. Kate scores 40% in the same test. Who has the higher score? Circle Hassan or Kate and explain how you know. I must make it clear at this point, you won't get a mark for circling the correct name. It's the explanation that they're really focusing on. So I wouldn't model anything at this point. I would ask the children to work together in groups of 2s or 3s, nothing more than that, otherwise it gets too big. And they have a discussion, how would they attempt that? And I usually give them 2 minutes. So before I model it, have a go. What would your explanation be? Now, again, again, I wouldn't model it. I'd ask a child to come up and model this before we looked at the question. So if Hassan scores 40 out of 80 in a test, if I reduce that fraction to its simplest form, I can actually already see that 40 and 80 are both multiples of 40. 40 goes into 40 once, 40 goes into 80 twice. So 40 out of 80 is equivalent to a half, which a half is equivalent to 50%. Kate scores 40% in the same test. Well, who scored the highest score? Well, Hassan scored 50% and Kate scored 40%. So it's Hassan. Explain how you know. Because. Now again, they can use this part in their answer. They don't have to write 40%, 40 out of 100 is equivalent. They don't have to write out that. They can put it mathematically into a much concise way. So because 40 out of 80 is equivalent to 1/2, which is equivalent to 50%. I'd write that in my bubble. Therefore, Hassan has scored 50%, which is higher than Kate's score of 40%. So that's something that you're looking for. Now, obviously I know everything won't be exactly like that. So what I would do there is I would put out some examples of what actually does the mark scheme say. And you can see here it's an explanation which correctly compares two percentages or two scores. And that, at that point there, would be the end of the lesson. I would tend to put all of those answers in a basket. I would pull out the raffle ticket, and if that raffle ticket was the correct answer, they'd get a little prize. And what that would be up to the teacher. I hope it's been really helpful in terms of seeing our structure, and that's quite a useful lesson. Thank you.